One more example, a fraction, a rational function. So let's consider f of x defined by 2x plus 1 divided by 3x minus 4. And we're looking for the derivative. Again, we start with the definition, and we just substitute, as usual, the expression for f of x plus h and for f of x. For f of x plus h, we just again substitute x plus h for x in the expression of f. This is what we obtain. It's not very friendly looking. However, at the top we have a difference of two fractions, and one thing that we could do is combine them as one fraction. In order to do that, we need to have the same denominator. This denominator is going to be the product of the denominators. So if we write each fraction with a denominator 3x plus h minus 4, or this multiplied by 3x minus 4, we have to multiply the top of the first fraction by 3x minus 4 and the top of the second fraction by 3 times x plus h minus 4. We obtain this expression here, and of course we could write that with just the h at the bottom of the fraction at the top instead of having 3 layers as we have here. Now we expect that as h goes to 0, at the top we have something that is polynomial in h and is 0 when h is 0, so we should be able to factor h out. How do we do that? Well, we want to factor, so one way would be to multiply everything through, simplify what we can, then factor h out of what remains. But since we want to factor, we can try to do that maybe a little more quickly. We can observe, for instance, that 3x minus 4 is multiplied by 2x plus 2h plus 1 in the first term, and by negative 2x plus 1 in the second term, and then there will be a remaining expression. So if I do that, factor out 3x minus 4, you see that it's multiplied by 2x plus 2h plus 1, and also by negative 2x plus 1. The term that remains is simply 3h multiplied by negative 2x plus 1. Now, inside the second factor, when I have the first factor 3x minus 4, I can cancel out plus 1 minus 1 and 2x minus 2x. I end up with 2h multiplied by 3x minus 4 minus 3h multiplied by 2x plus 1. And as expected, that means we can factor h out. In doing so, I obtain 2 multiplied by 3x minus 4 minus 3 multiplied by 2x plus 1, all this multiplied by h, and now I can cancel my common factor h. In what remains, I can plug in h equals 0 and I get something that now is well defined. I obtain 6x minus 8 minus 6x plus 3 at the top. At the bottom I have 3x minus 4 multiplied by 3x minus 4. In other words, 3x minus 4 squared. So f prime is, after simplification, negative 11 over 3x minus 4 squared. Now to finish with our example and applications, let's assume that we have a solid that moves along a straight line with law of motion s equal t squared plus square root of t, where the position s is measured in feet and the time t is measured in seconds. And let's say we want to find the velocity after 2 seconds. In other words, we have the position function s of t, which is t squared plus square root of t, and what we're looking for is a derivative of the position at time 2. By definition, it's a limit when t is approaching 2 of s of t minus s of 2 over t minus 2. If I substitute for s of t its defining expression and for s of 2 the value of the function at 2, I obtain this expression. Now we typically don't deal the same way with this type of difference quotient for polynomials and for expression containing radicals. So here we have a mixture of both, but we can just split it in two parts. I can rewrite this expression as t squared minus 4 divided by t minus 2 plus root t minus root 2 divided by t minus 2. In both fractions, I have the situation that when t is 2, I get 0 over 0. So I have two terms. Each one of them is an indeterminate form of the type 0 over 0. In the first case, it's a quotient of polynomials. The fact that it is 0 at 2, both at the top and the bottom, means t minus 2 is a common factor. So to lift the indetermination, we're going to just factor t minus 2. In the second case, we have radicals. So before we can do that, we're going to multiply top and bottom by the conjugate root t plus root 2. So this is what we obtain. The top in the first fraction factors as t minus 2t plus 2. And in the second fraction, I multiply top and bottom by the conjugate. In the first fraction, I can cancel the common factor t minus 2, and what remains is t plus 2. In the second fraction, at the top, I have something of the form a minus b, a plus b, so I obtain the difference of the squares. The square of root t is t, and the square of root 2 is 2. So here is what I obtain, and you see the common factor t minus 2 appearing at the top and the bottom of the second fraction. After cancelling it, we obtain the limit at 2 of t plus 2 plus 1 over the square root of t plus square root of 2. This is well defined when we plug t equal 2, and we obtain 4 plus 1 over root 2 plus root 2. Rationalizing, we obtain 4 plus root 2 over 4. In other words, the velocity after 2 seconds is 4 plus root 2 over 4 feet per second. Now it's time for you to try doing some homework.